Hi everyone, how are you? I hope all is well. Today I'm here with a very recent exam question. This is question 15 from paper 1 from the May 2025 exam. So let's get started. The diagram shows wavefronts of light incident on an air glass boundary. So the first thing that I think of when I see wavefronts like this is that they're meant to represent a light ray. So if I had to visualize and draw, our incident light ray would probably be something like this. The next thing that I can do right after this is draw a normal line, because if light ray is being reflected or refracted, I always have a normal line. So this is our normal line. The next knowledge that an IB physics student, of course, should have is glass is denser than air. If the question doesn't give us anything, the refractive index of air is going to be probably 1, and glass is denser than air. So when the light ray travels from the air medium into the glass medium, it's going to be slower as it's traveling into a denser medium. So this is going to be our angle of incidence, and then our angle of refraction is going to be here. The angle between the incident wavefront and the normal n is theta, okay. Which of the following gives the correct expression for the refractive index of the glass, which we'll represent with ng, where r is the angle of refraction. Okay, the angle of refraction we can see here is r. So if we had to construct a formula, let's say n air, which we're going to count as 1, over ng equals sine r over sine theta I. So angle of incidence, let's say. The next thing we'll do here is the first thing that I personally notice here is that there's some kind of triangle here. So if you remember basic math, this resembles a butterfly shape. And the special thing about this butterfly shape, which is two triangles placed against each other, was the angles that you can see here are going to be equals. And then if you had to, on top of this, remember another trick, which is the Z formula or Z trick, whatever you call it. This angle right here has to be equal to this one here. So this angle is going to be theta. What this leaves us with is, is the fact that the angle you can see here is theta. So the angle of incidence has to be 90 minus theta as the rule of the triangles, obviously. So angle of incidence is going to be equal to 90 minus theta, as these are equal. This is theta, this is theta. Of course, this is going to be 90 minus theta. Okay, so the next thing we'll do here is NA is 1, and G is going to be equal to sine angle of incidence, theta I, over sine R, which is going to be sine 90 minus theta, and then sine R. So if you look at the choices, B is the one that corresponds to our answer. So B is the answer of our question.